Hello students, welcome to column chromatography online, which is like column chromatography in person, but not quite as fun. That being said, let's get right on to it. Now in this experiment, we're going to use column chromatography, and we're going to separate the three compounds that are active ingredients in headache powder. Those compounds are aspirin, acetaminophen, and caffeine. So here are the structures of the three molecules we'll be separating. Aspirin on the left, which is the least polar, acetaminophen in the middle, which is a little more polar than aspirin, and finally caffeine on the right, which is the most polar of the compounds we're going to be separating. Now these three molecules are listed in order from least polar to most polar. Now we're going to take advantage of this difference in polarity to help separate these molecules and isolate them. But you ask, how will we separate these molecules by polarity? If only someone had invented something that could do that. Then we could all get good grades and go on to become doctors and drive nice cars and have big houses. Well, you're in luck. In 1918, Walter Patrick invented your new best friend, silica gel. Now, silica gel had been known about since the 1640s or so, but the method of making it was very difficult and not very cost effective. It wasn't until around 1914 or so that Walter A. Patrick invented a method to make it that was both economical and you could mass produce it. It was originally used in gas masks during World War I and to store penicillin to keep it active, none of which you probably care about. But let's look at the structure. It's made from silicon dioxide and held together by siloxane bonds. This arrangement leads to an amorphous and very porous substrate, which will come in handy for our chromatography. On the surface, you'll see a lot of silanol groups. This leads to the surface being fairly polar. And that is what we're going to take advantage of to separate our three compounds, and then you can all get good grades and move on with your lives. So how is this going to work? Well, we're going to pack a column with silica gel, which is going to be our stationary phase. We're going to dissolve our three compounds in hexane ethyl acetate, which is going to be our mobile phase. Now, as our three molecules travel through the column, they're in solution, but they're going to come in contact with the silica gel particles. The more polar the molecule, the stronger that interaction is going to be. The result is the least polar compound will elute first, and the most polar compound will interact most with the silica gel particles and elute last. In this animation, aspirin, least polar, is red. Acetaminophen is the green triangle. That's more polar than aspirin. The most polar is caffeine, which is represented by the yellow square. Now when I run the animation, you'll see our three compounds elute just like I told you they would. The least polar aspirin came out first, the acetaminophen came out second, and the most polar caffeine came out last. Let's hope your experiment works as well. Okay, enough theoryland and background. Sorry folks, but you're not getting those 3 minutes back. Let's get in the lab and do some real science, or at least enough science to get a good grade. First, you're going to prep your column. To prep your column, you're going to weigh out two 250 milligram portions of sand, which you're going to put above and below the silica gel. Then weigh 3 grams of silica gel. Once you have everything weighed out, take the materials back to your hood, and you're going to pack a layer of sand In the bottom of the column, tap it to settle the sand down and pack it down. Then add your gel, again, tapping to settle everything in and pack it nice and tight. Then add another layer of sand on top of the gel. It's important to tap the column every time you add a layer because you don't want any air pockets in your column. This will disturb the chromatography and the experiment will not work as well. So after you add sand or gel to the column, make sure you tap the column to settle everything in and help it pack in tightly. Now it's time to prepare your TLC plates. Get 3 TLC plates. Draw a line about 1 centimeter up from one of the ends. Put 3 X's on that line. This is where you're going to spot your fractions. Each plate will have a standard that'll be provided to you and 2 of your fractions. When you're done, the first plate should have a standard and fractions 1 and 2. The second plate should have a standard and fractions 3 and 4. And the last plate will have a standard and fractions 5 and 6. While you're preparing the plates, you can go ahead and spot the standard on them. Once you have prepared your TLC plates, it's time to get your vials for your fractions. Make sure the vials are clean and dry, and then weigh each vial to get a mass before fraction collection. You're going to need this because once the fraction collecting is over, we're going to dry down the fractions and weigh how much material you have collected in each vial. Once you've recorded the masses of the files in your notebook page should look something like this. Now you'll notice that I recorded one of the masses incorrectly when I was filling out this page, which is fine. All you need to do if you make a mistake is draw a single line through the data and write in the correct data. No need to scribble it out, no need to start over. Just correct the mistake and move on. Now it's time to weigh out our headache powder. Get a packet of powder, weigh it out on the balance, record the mass, then take the powder and put it in your column. Again, make sure you knock the column gently to settle the powder in and remove any air bubbles. You may want to pack it in with a wooden stick or the tip of your spatula. Now it's time to elute our column using 2-to-1 ethyl acetate hexane. You should have gotten about 20 mils of this. Using a pipette, add the ethyl acetate hexane solution to the top of your column. From now on, you do not want your column to ever run dry, so make sure you keep the level of the liquid above the level of the powder. You should be able to watch the liquid move through the column as it seeps through. Make sure your flask for fraction 1 is under the column, ready to catch the drops as they elute. You're going to elute about 5 mils before you change flasks. You will also want the tip of your eluting column to be somewhat in the flask as shown. This will help stop deposits from solidifying on the tip of your column and plugging the system up, making the lab last even longer. Continue to collect fractions. After you have changed from fraction 2 to collect fraction 3, change your mobile phase to ethyl acetate. Collect fractions 4 and 5 using ethyl acetate as your mobile phase. When you switch to fraction 5, switch your mobile phase to acetone and use acetone to collect fraction 5. When you have collected fraction 5 and begin collecting fraction 6, again switch your mobile phase to methanol and use methanol to collect fraction 6. As you are collecting the fractions and pulling them off the column and spotting them on your TLC plates, once they are spotted, begin drying the fractions down using the air from the hood as shown. While you're watching the video, notice that the column never goes dry. Do not ever let your column dry out. That will totally ruin the experiment. Make sure you keep solvent in the column at all times. As you are spotting the TLC plates with your fractions, you can check to make sure that you've put enough material on the TLC plates by looking at it with the UV lamp. You should see the spot on the TLC plate. Once all your TLC plates are spotted, you can develop them in the TLC chamber. Don't forget to draw the line across the solvent front when you pull them out. Once the plates have developed, look at them under the UV light and circle the spots that you see. You will use these spots to calculate the RF values for the individual components. Once you have most of the mobile phase driven off from your fractions by the air, you can then place them on a warm hot plate. About 70 degrees is fine on the hot plate. Leave them on the hot plate until you have driven off the rest of the solvent. You should have a white powdery substance left. Then, once the solvents have been driven off and the vials are dry, you can weigh them to find out how much material you collected in each fraction. You will use this data to calculate your percent recovery. Here you see the final masses of each vial in our laboratory notebook. To remove the media from the column, you may have to hook it up to the compressed air and use that to blow the column out. Make sure to put all waste in the proper waste containers.